Okay, in this lesson, we're in Unit 5. We're just going to look at quickly rewriting from radical to exponential, and then we're going to rewrite from exponential to radical, and then we're going to look at evaluating expressions. So remember, we just started looking at the fact that the square root of 4 could be written as 4 to the 1/2 power. And the cubic root of 4 could be written as 4 to the 1/3 power, and vice versa. So we could write 5 to the 1/8 power, we could say, could be written as the 8th root of 5, and back and forth. Right? You could write the 7th root of, say, 9 could be written as 9 to the 1/7 power. 3 to the 1/2 power could be written as the square root of 3. So those are some things that we went over just recently. So let's look at rewriting. Let's start and go from radical to exponential. So we're going to rewrite and do from radical to exponential. So if you had the 4th root of -2, we could rewrite that as -2 to the 1/4 power. However, the radicand, which is underneath the radical, is -2. So the fact that this is the radicand is -2, you must have a parentheses around that base. So you must have a parentheses around that base. If you had the square root of 10 being raised to the 5th power, remember the square root of 10, so the square root of 10 could be written as 10 to the 1/2 power, and then that is being raised to the 5th power. And remember, when you have a power to a power, you multiply. And how do you multiply fractions? Don't you put a 1 underneath that? Don't you multiply the numerators when you multiply fractions? And don't you multiply the denominators when you multiply fractions? So doesn't that give us 10 to the 5/2 power? So this in radical form could be written as 10 to the 5/2 power in exponential form. Number 3, what if we had the cubic root of 7 being raised to the 2nd power? So the cubic root of 7 could be 7 to the 1/3 power and then squared. And then when you have a power to a power, you need to multiply. So when you multiply 1/3 times 2, doesn't that give you 7 to the 2/3 power? And then you might notice a pattern. So did you notice that the index turns out to always be the denominator of the fraction? Since this is squared, isn't the denominator 2? And notice that the exponent is the numerator, and notice the exponent is the numerator. So if you notice that pattern, can we get to the point where we can just jump and skip that middle step? Otherwise, we can go to that middle step to help us. So if we have the 7th root of 8 to the 5th power, can't we write that as 8 to the 5/7 power? And if you're stuck on that, we can do the work. Notice where everything's coming from. And if you're saying, well, how did you get that again? Well, I noticed the pattern earlier, but I could rewrite what's inside. So I could take what's inside and say, isn't that 8 to the 1/7 power raised to the 5th power? And then when you multiply power to a power, isn't that what you get? So what if we have, the square root of 5 to the 1/3 power to the 1/4 power? Inside, isn't that 5 to the 1/3 power being raised to the 1/2 power, which is then being raised to the 1/4 power? Right, so there's my radicand. So my radicand is 5 and 1/3 is my radicand, and its square root could be written to the 1/2 power, and then that is all being raised to the 1/4 power. And then I have a power to a power to a power, so I can multiply all of those by multiplying the numerators. So 1 times 1 times 1 is 1, and then 3 times 2 is 6, times 4 is 24, so it's 5 to the 1/24th power. So just going from radical to exponential, radical to exponential. So what if I have negative fifth root of n squared that would be negative n to the 2/5 power. And if you're saying why is that, and I wouldn't have the negatives on the outside, so I actually would not have a parentheses around that base. So again, that would be like saying -1 times, and then n squared to the 1/5 power. And then when you do a power to a power and you multiply, that's how you end up getting that. So let's go the other direction. What if I give you something in exponential notation, and I want you to go from exponential and I want you to rewrite it in radical notation? So from exponential to radical. So if I say -5 to the 1/3 power, that could be written as the cubic root of -5. If I didn't have the parentheses around that, then that negative would be outside of the radical, right? Because only the 5 is the radicand, right? Only the 5 is the base, so only 5 is the radicand. Where here, -5 is the base, so -5 is the radicand. What if I have 2 to the 3/5 power? Can't that be written as the 5th root of 2 to the 3rd power? Or you could write that as the 5th root of 2 to the 3rd power. Now this is the one I like the most, where the to the 3rd power is on the outside versus the inside. So I like that one better, but remember the denominator is the index of the radicand, right? But you should, on that one, you should have it written both ways. So going from exponential notation to radical notation. So if you had 3 to the -1/2 power, you can think of that as the square root of 3 being raised to the -1st power, right? Because your index is, your denominator is 2, so your index is 2, which is a square root. And then you can't have a negative exponent, so if you go back to your rules of exponents, we'd have to write that as 1 over the square root of 3. So that would be your final answer. So going from exponential to radical. So if we had -5 to the 1/2 power, that would just be negative square root of 5. What about 1/3 to the -1/7? So there's a rule that says if you have a negative exponent, you can reciprocate the base, so that 1/3 could become 3, and that will make the -1/3 become, or -1/7 become a positive 1/7. And then since this is 1/7, that means the index is 7, so that would be the 7th root of 3. That would be the 7th root of 3. Compare that to problem number 7, where you have 5 to the -2/3 power. You can think of that as the cubic root of 5 to the -2nd power. And then you can't have a negative exponent, so that would be 1 over the cubic root of 5 squared, or you could write it as 1 over the cubic root of 5 with the squared inside the radical versus outside the radical. So it's good to know both of those, right? So that's just a little examples of going from exponential to radical and radical to exponential. And then evaluating without a calculator. Evaluate without a calculator. So what would the 4th root of 81 equals what? So remember, you're thinking in your head, what could you possibly raise to the fourth power that would equal 81? Is it 2 times 2 times 2 times 2? 3 times 3 times 3 times 3? Is it 4 times 4 times 4 times 4? Which one would give you 81? And obviously it would be 3. So 3 to the fourth power equals 81. So this equals 3. So 3 is your final answer because that's what you're thinking. Right now, technically, it could be plus and minus 3, but when we're just asking for the fourth root of 81, we're just really asking for the positive root. If I give you 8 to the 1/3 power, remember 8 to the 1/3 power is just a fancy way of writing the cubic root of 8. And then we're thinking in our head, what could you actually raise to the third power that would equal 8? Is it 2 times 2 times 2 or 3 times 3 times 3, 4 times 4 times 4? So that would equal just 2, right? Because 2 to the third power equals 8. So your answer is just 2. If you have the cubic root of, or how about the square root? No, we'll do the cubic root of negative 27. So we're thinking, what could you raise to the third power that would equal negative 27? So obviously it has to be a negative answer. So is it negative 2 times negative 2 times negative 2? Nope. Is it negative 3 times negative 3 times negative 3? Yes. So this answer is negative 3 because negative 3 to the third power equals negative 27. So your final answer is negative 3. So this has a value of negative 3. What about number 4, the 6th root of negative 64? So we're thinking, right, in our cloud, we're thinking, what could you raise to the 6th power that would give you a negative 64? And remember, when you take a negative number to the 6th power, that will always come out to be positive, and a positive to the 6th power is always positive. So how are we going to get this negative? So you cannot, remember, if you have an even index and a negative under the radical, there's no way that can be done. So that is going to be no real answer. It's an imaginary answer. We're not looking for imaginary answers in this unit. So there's no real answer for this, right? Because we're not looking at imaginary. There's no way you're going to be able to get a negative answer when you have an even power. Because no matter what you raise to an even power, it's always going to come out to be positive. So how are you possibly going to get it to be negative? So hopefully that gives you a little bit of an idea of part of your homework. Maybe let's do some negative ones. Let's maybe do a negative one. If you have the number 5, if you have, say, 2/5 to the negative 2nd power, remember we could rewrite that as 5/2 to the positive 2. So remember, to get rid of a negative exponent, you can rewrite that as positive by flipping the base, right? By putting the 5 on top and reciprocating. It's called reciprocating the base. And then remember, 5/2 squared means 5/2 times 5/2, which gives you 25/4. Now be careful if that was, say, 1/4 to the negative, or to 1/2. Remember, that would be the square root of 1/4, which would be the square root of 1 over the square root of 4, which would be 1/2. Or what if it said 1/9 to the negative 1/2? To get rid of the negative exponent, we could reciprocate that and make that positive 9 to the positive 1/2, which then means the square root of 9, which is then 3. So really understanding how to go from exponential to radical, working with negative exponents, and knowing the rules of negative exponents. So I hope that helped you out.